today's class is stress transformation. Before we get into the detail of stress transformation, we want to go to review about cow member. So get review. Cow member, if you recall, that is a centric axial loaded member. So let's put that member out here. And we have a load P in both sides, and the transverse cut, and then if form any cut that form an angle theta from that cut, and that angle theta is definition from the transverse cut to that plane, and that we call theta. And from lesson 1 we know the stress on that plane form an angle theta from the transverse cut, sigma equal to P over AT cosine square theta, and then the tau shear stress equal to P over AT sine theta cosine theta. And if you don't recall that, go back to lesson 1. I just go to review worksheets 1F that we have it very first lesson. We have a transverse cut in here with the areas is 0.785 inch square, that is a transverse area, and then the force P equal to 25 kips. So with any cut that form an angle theta, in this case we vary from 0 to 180 degree. And you can see the sigma is the curve on the graph with the normal stress KSI, kips per square inch in blue, and the tau, which is the shear stress, in the red. And you can see there the maximum of the sigma normal stress at angle theta equal to 0, and also of course 180, and it gets 0 at 90 degree. 90 degree of theta, it means that your plane, the cut is parallel to the longitudinal axis. And for the tau, which is the shear stress, is 0 at 0 degree and 90 degree, and maximum at 45 degree. Intuitively speaking, when you see the graph here, the tau max at 45 degree is half of the sigma max. And right here with the number, you can see that at 0 degree, the sigma equal to 31.85 KSI, and at 45 degree, tau equal to 15.92, so that the maximum tau get is half of the sigma max. So from that one here, let me go to summary of what we have it in worksheet 1F that we have there. So here, if we have two X and Y, and that one angle theta that we use, and this is stress for the vertical axis. And for that one, for the normal stress that it in blue, as you can see, it get maximum at angle theta equal to 0, and then we have 90 degree, the sigma is 0, and the other angle that we want to deal with is 45 degrees. So what is the behavior of the sigma normal stress? It will be maximum at that point, and it will be a sine curve, and then it go to 0 at 90 degrees. So that is sigma. And for the tau, it will be 0 at the angle theta is 0 degree, and it also 0 at the 90 degree, and get maximum at 45 degree, and it about half of exactly half of the sigma at 45 degree. Why half? As you can see, if theta equals 0, then cosine theta equal 1. So you have sigma equal to P over AT, right? But tau half, because 45 degree, you have sine 45, cosine 45, it equal to 1/2. That's why the tau max is 1/2. So from that, we can draw a sine curve for that one. Sine curve here. Get the maximum at 45 degrees and going down again to 90 degrees. So that's what we have for the tau. The red one is tau, and you can see that. So let's make a few notes in here. We have sigma max will reach at angle theta equal to 0. So in this case, equal to P over AT at theta equal to 0 degree. And then also sigma mean, it means 0. And you can see that at the angle theta equal to 90 degree. And we also have the tau maximum and tau max, as I mentioned, at 45 degrees. Plug in that equation, we have it equal to sigma max, which is P over 80 divided by 2 at theta equal to 45 degrees. So that is the review of the lesson we have before we move on to do the stress transformation.